For decades, military aviation has been all about one thing: performance, speed, range, and survivability were the only metrics that mattered. The environmental cost, just a necessary evil. But that entire way of thinking is now being turned on its head. Welcome to the new era of supersonic sustainability. Now, when you hear sustainability, you might think of compromise, of dialing back on power. But in this world, it's the exact opposite. It's about a fundamental shift in engineering priorities, where efficiency is not a weakness, but a weapon. Modern military programs are now treating fuel efficiency, emissions, and even the life cycle impact of an aircraft as critical operational constraints. So, what's driving this massive change? It's not public pressure, it's logistics. In any conflict, fuel is life. Your fuel supply chain dictates how far you can go and how long you can stay there. By slashing fuel demand, you dramatically increase a jet's endurance and make your supply lines less vulnerable to attack. Sustainability isn't just a moral goal anymore, it's a powerful force multiplier. At the heart of this revolution are adaptive cycle engines. These are Imagine an engine that can literally change its shape mid-flight. When a pilot needs maximum power for a dogfighter to go supersonic, the engine configures itself for high thrust. But during long-haul cruising, it shifts into a super-efficient mode, drastically reducing fuel burn. This has incredible benefits. Not only does it lower emissions, but it also reduces the engine's heat output. A cooler exhaust makes it much harder for heat-seeking missiles to lock on. Suddenly, environmental efficiency and combat survivability go hand in hand. Materials science is also playing a huge part. We're seeing the use of advanced ceramic matrix composites. These incredible materials can handle much higher temperatures than traditional alloys, but are significantly lighter. Lighter aircraft need less thrust to fly. Less thrust means less fuel burned. It's a beautiful chain reaction that boosts both performance and efficiency simultaneously. Even the stealth coatings on these jets are evolving. The toxic, high-maintenance coatings of the past are being replaced with durable, less hazardous formulas, reducing both the environmental footprint and the workload for ground crews. And what about the fuel itself? Air forces around the world are seriously testing synthetic aviation fuels. These e-fuels burn cleaner and can often be produced domestically, which is a huge strategic advantage. It reduces dependence on volatile global oil markets and vulnerable tanker fleets, all while cutting down on particulate emissions. Noise is another big consideration. The bone-rattling roar of a supersonic jet can be a major problem for communities near air. So, engineers are developing advanced engine inlets and exhaust nozzles that are specially shaped to reduce the noise footprint during takeoff and landing. This allows pilots to train more frequently without causing massive disruption. Behind the scenes, digital engineering is making a quiet but massive impact. By using incredibly detailed computer simulations, designers can perfect an aircraft's design before a single piece of metal is ever cut. This drastically reduces the number of physical test flights needed, saving millions of gallons of fuel during the development phase alone. It accelerates programs and cuts environmental costs at the same time. And we can't forget about autonomy. Unmanned platforms, or drones, are inherently more efficient. They're often smaller, lighter, and don't need the complex life support systems that a human pilot does. They can stay on station for incredible lengths of time, extending a mission's reach without the physical limitations of a person in the cockpit. Even how these aircraft are maintained is becoming smarter, instead of replacing parts on a fixed schedule. Predictive diagnostics allow crews to service components based on their actual condition, reducing waste and the logistical burden. Let's be clear. Supersonic sustainability won't eliminate emissions entirely. Military aviation will always be a resource-intensive business. The goal here is controlled, strategic expenditure, not unchecked consumption. These innovations are a direct response to the new realities of modern warfare, where contested logistics and long-term readiness are paramount. An aircraft that can fly farther and fight longer with less support is simply a superior weapon. So, the next time you see a future fighter jet streak across the sky, know that it represents more than just raw power. It's a marvel of endurance, efficiency, and control. Supersonic flight has always been a symbol of power, but sustainable supersonic flight, that's a symbol of smart, enduring power. Thanks so much for watching. If you found this look into the future of aviation interesting, be sure to like, subscribe, and hit that notification bell so you don't miss our next video. See you next time.